Hello and welcome to the next session of Foo-Bar Java Review Sessions. My name is Zan Rizvi. Will be your host for this evening. In today's session, we are planning to cover file I/O and exception handling. And then just want to do a check if we actually have people in the audience or the viewers. Please let me know if you're here. And if you can also confirm if you could hear me properly, plus the microphone is set up, camera is also set up properly. This way, we don't waste a whole session with some kind of technical difficulties going on without my knowing. Normally, I try to do these kind of checks before the actual stream by doing a recording, but just to be safe. And if it turns out that we don't have anyone in the chat, I'm just gonna wait about 10 minutes, and if no one shows up, we can call it an early evening. As I mentioned before, I don't like just talking to myself. These are meant to be a live session as compared to just a recording. So if you are there in chat, please let me know. All right, while we wait, actually see if I can find a viewer count. All right. Looks like we're still waiting. Or perhaps this was not a topic that people wanted covered. Hopefully people can hear me in chat. All right, we have Storm Quaza. Welcome. Part 4. Okay. Seems you might be the only one here, but let's get going anyways. Well, welcome and thank you for attending. So yeah, since this is one-on-one, we can actually make it quite detailed towards your needs, whatever you, if there's things that you want me to speed up on or slow down, or specific things you want me to cover about the topic, feel free to let me know. This is a very one-on-one session, I guess. Essentially what we had in mind, once again, we had file I/O and exception handling. I just got to do the disclaimers first. Once again, this is a personal channel. It's not part of my TA duties. I'm a graduate student at the University of Calgary. As part of my being a graduate student, I get to be a teaching assistant for the Computer Science 233 course this semester, which is the Introductory Java Programming and Object-Oriented Programming. These sessions are geared towards students in these courses, but once again, they're meant for extra help. Yeah, feel free to, as I mentioned, feel free to discuss things in chat. That's common courtesy, keep things clean, no spamming. And then, since we do have someone here, and the session will go on, so we will, I will post a video online, the YouTube channel later on today. So let's get started with file I/O and exception handling. So first thing we'll do is a file I/O example. So I'm going to call my driver class. And what we're going to be doing is being able to read from a text file and then writing to a text file. This is supposedly fairly straightforward, but a lot of times people just want to see an example going, and not just read some code someone else has written, but actually have a live coding example to see what's going on and then what kind of mistakes to be made and how to handle them. Let's get started. So first thing we will do is actually read from a file. So before we even write any code, we can create ourselves a a text file to read from. And then this would be a untitled text file. And then I'm just going to put in some text here. Hello world, 1, 2, 3. I'm going to put my name and session 4. And this is going to be in session 4. Let's just call this input.txt. This is our input file. Now, we have done a bit of input reading from the console earlier in this course, so this is not that much different. Instead of stuff being typed on the spot, this is just stuff which has already been typed or inserted into some kind of input file. So we would, in order to do this, we have a scanner. This should be familiar from console input. And we're going to initialize the scanner in a try statement. First, I would like you to just take this as is, and then we'll actually go over as to what's going on with the try and catch. And that's for exception handling. So we create the scanner as an initialize the object. And instead of saying system.in, we actually specify a system input stream. And then here, we put the name of our text file that we want to read from. And then always import the correct files that we need. And once we have the input file, I'm just going to do a very generic exception. Once again, we'll come into the details after we've done the file IO stuff. And then I'm just going to do, sometimes it slows down the computer, not sure why. And system.exit. So essentially what's happening is, just a brief overview, we try to create a scanner while reading from this file called input.txt. If something goes wrong, the system is going to print the error stack or the stack trace and then exit. That's essentially what we're doing so far. Otherwise, we're going to keep reading from the file. And this is, again, the scanner works similar to what we've seen when you're working with the console input. As long as the scanner has something to put or something to read from, and I'm going to read line by line. You just want to print whatever's in the line. I want to initialize the scanner. And it's important that we do this scan equals null up here, because otherwise it would give you an error here saying that scan might not have been initialized. So we initialize it to null. We assign a value here. And then we want to read and print each line. Now, if we did this right, in the console, we should be seeing all the input we put in our text file, which is hello world, 1, 2, 3, Zen Rizvi, and session 4. So this worked as expected. Now, we don't have to read only one line at a time. We can do certain other things as well. So for that, I would forward you to the Java API. So we just Google the Java API. Now this, what you see here is a documentation that's created when you actually use Javadoc properly. This here is all the packages. So up in this corner are all the packages available that are found in Java library. These are all the classes. And then this is the description essentially for all the packages. So the class that we're looking for is called scanner. And what we're trying to do is, what are the things that we can do? So let's see, element scanner, here we go. There's scanner. If you look at this class, it gives us the basic description of the class here. And how to use it, what kind of values there are. This tells us what constructors are available for the scanner. And then here are all the methods. every single method that's available with the scanner class, with the description and the return type. In the left column here, we see the return type. In the right column here, we see the method name, the signature, what kind of arguments it needs, and the basic description. So we use the method has next line, or rather has next. So we can find, these are alphabetically sorted, so we find has next right here, and this gives us the whole description. Returns true if the scanner has another token in its input, and so on. So this comes in really handy when you're trying to do extra stuff and you don't know what kind of methods are available to you. If you're using an IDE, I know when you do something like scan dot, it gives you a list of everything that's needed. Really handy, but this is not always available, especially if using a basic text editor. This is where the API comes in handy. So instead of reading one line at a time, let's say we just want to read one token at a time, meaning one word. So if you were to look at our text file, or rather the output here, hello would be a word, and then hello, and then world would be a second word. 1, 2, 3 would be a word because they're space and new line separated. We have the word Zan, and then again another space separated, and then a second word Rizvi, and so on. So if we were to do this and then run it, it prints every word on a single line. So recall earlier, hello world was on a single line, Zan Rizvi was on a single line, session 4 was on a single line, but now each single word is on its own line. That's one way we can do one word at a time. And then there's a whole bunch of methods here. So feel free to go through all of them, and then you can read like one byte at a time here. Let's see if I can get this a bit bigger. Byte, a float, int at a time. We've already seen a line at a time, and then short, which is another type of number. So yeah, we can read quite different types of things as we need. So that comes in really handy. And when you're working with a very basic file IO, or at least the file I part, the input, this is it. This is all we need to do. Initialize a scanner with the file input stream, specify where the file is. And then, so let's say if this file was actually in a different folder, so I'm going to actually create a new folder. Within session 4, I'm going to call it input files. I'm going to put my input.txt into that particular file. Then it would be input files/input. The reason I need these two backslashes is because in Java, backslash is an escape character. So that's why we need to actually specify that we're saying it is a backslash. So if I did this right, it reads everything properly. If I get rid of this input file, whoops, what did I do there? Yeah, if I keep it as is, after I've moved my file into a different folder, but I haven't changed the address here, try to run it, it's going to give me an error, more specifically, file not found exception. But we'll get into more detail about exceptions once we have looked into actually writing to a file. So I'm going to close this here. And then another thing that we want to do is after we've done the file, we also want to call scan.close. This is a way to tell Java, actually close the file, stop holding on to this resource. The resource being our input file. And then this makes it that other applications are able to access that file. Because when you have multiple applications accessing the same file, stuff can go wrong, especially if they're writing to the file. So we can do input files this way, and the example works properly. And now we actually want to do write to a file. So once again, it works very similar. We want to initialize a print writer. I'm going to call this writer equals null. We're going to follow the same structure Okay, we actually have a question. Can you break down what each line of code does? I've been lost a little in the class, but I'm slowly keeping up. Like the try and catch, etc. So Storm, we are going to come back to these two particular blocks of code, the try and the catch. We're going to come back as soon as we are done actually writing to a file. So the exception handling we'll come back to next. Do you have any questions about this particular line scanner or what's happening in this while loop? Okay, the rest of it makes sense. Good. But yes, we will come back. And if I forget, please remind me, because these are the 3 topics that we are covering today. Exception handling is important. Okay, so we do a print writer, and then again we start here, and then writer equals new print writer, new file output stream. So notice when we're reading from a file, we have a file input stream. When we are writing to a file, it's a file output stream. And hopefully the names are straightforward. Input files, output.txt. Then catch, exception E, system.exit, again 0. Now we want to import everything that we need. I love this feature with Eclipse, or pretty much most IDEs have this, and that is you just press a button and it just puts in all the import statements that you need. So it's really helpful. Okay, and then let's say what we want to write to a file. What we can do is let's try writing the numbers 1 to 10 to a file. So for that we would need a for loop. I equals 0, I less than 10, I plus plus. And then we would do writer dot print I plus 1, because we said we are writing 1 to 10, not 0 to 9. That's an important distinction. And then again we want to do writer dot close. This is where the closing really comes in handy, because if you're having multiple files write to the same, if you have multiple applications writing to the same file, unless you close the file appropriately, it could lead to errors. It could be even the case that unless you close it, everything that you want to write to a file does not get written. Because what happens is Java first holds everything in memory in what's called a buffer. It's going to keep adding the stuff that you want to write to a file, adding it to the buffer, and then when that buffer is full, then it's going to flush everything onto the file. So it tries to do a bit of lazy approach. It's just going to keep storing what you tell it to write, and then once it can't store anymore, then it's going to write to the file. Now, if you don't close the file properly and that buffer is not full, then all that data that you were trying to write may get lost. So that's why it's really important to close the buffer, or close the print writer. Okay. Now, if we actually run the code, we actually do see a problem, and that is input files input.txt cannot be found. I just had that working. Oh, and that's because I misspelled input. This happens. So we do have the content from our input file. If I open this up here and hit refresh, I have a file called output file. I open here. I think this text is a bit too small, so instead I'm going to open it in Notepad++. See, volume D. Then we have where is that folder called Foo-Bar, session 4, input files, and then here we see our output file, which says 1 to 10. And again, this is very similar to when we are printing onto the console. Anytime we want to print, instead of saying system.out.print, we just write writer.print. Then comments, documentation is important. Here we write to a file and we close the writer. Let's say if we actually do take this out, what happens? So I'm going to delete everything from this file. It's going to be blank. Then I run it. No errors, everything's good. It says the file has changed, so I'm going to reload, and nothing is coming in. So since I didn't close the writer, and I exited my application, meaning I exited my program, the buffer wasn't flushed. That's the proper terminology. So nothing was written onto this file. If I bring this back and then reload or rerun the program, file has changed. I want to get the newer version, and here we have the new text. Let's see what else. If you don't want to close the file, but you just want to make sure that the contents are written, we can always flush manually by calling the method flush. So if we get rid of this and run it, or rather I should,
hello,
and if we have a phone call, we'll be right back. Right. Sorry about that. Let's come back to the stream here. My apologies. Forgot to turn the phone on silent. And then we're talking about writing to a file. So we emptied our file. There's nothing in there. I've saved it. And then I try to run the program. And if you see here, the contents are being written to the file because I'm manually calling the writer.flush operation method. So if you don't do this, when we say writer.close, that calls the flush method automatically. So it's up to you if you want to do it one way or the other, but it is important to close the file. If you want to be really safe, you can do both. Okay. And then other things we can do is, so we can write, one line at a time. We can create strings. We started off as a blank string, and then keep appending something to it. Let's see, we append the letter or the value for I counter. Plus hello, why not? And then we can write writer.println and then str. So we can save information or save our text to a string and then actually write the whole string onto the print writer in one go, like this. Now if you run it, yes, you want the new version, and here is the new version. Now, one thing that you might have noticed is every single time I write to a file, it deletes whatever's already in it, and then it just overwrites the new stuff. But sometimes we don't want that to happen. We don't want the old data to be lost, we just want the new data to be there. So this way, we actually have to create our, I believe it's the file input stream in a different way, or perhaps it's or you know what, the best way to do it is to actually figure it out on using the Java API. So one thing we're looking for is a print writer. Here we go. We're looking at the constructors. So this one does not tell us anything. So what I'm looking for is the way to not override everything everything that's already in the file. So we have file output stream. Here we go. There's this one file output stream. We give it the file name and then a Boolean append. If I just click here, Boolean append. Okay, if the second argument is true, the bytes will be written to the end of the file rather than at the beginning. So I can simply do true. And now instead of counting from, let's say 0 to 10, let's count from 90 to 100. Just so we can see there's something different going on. And so if we run it again, then we reload our file. So you see the original content is still there, but the new content is added to the bottom. So this is, again, kind of comes in really handy if you don't want the original content of the file to be overwritten. But if you do want the original content of the file to be overwritten, then you don't need this extra value, or you can call this as a false. But since we do want to append, we just say true here. Those are the very, very basics of a file I/O. You saw reading from a file, and then we saw writing to a file. And then we saw writing by overwriting the file, or we're actually appending to a file. Do we have any questions about either of these topics before we move on to exception handling? I'll wait a few more seconds. Okay, I guess that looks like we don't have any questions about the file I/O component. I know there's a lot more advanced things you can do, like actually writing byte streams and all, but at this point we don't need that sort of advanced methodology in our projects. We just need something fairly straightforward. I know a lot of people for these projects, they do like a game development, and so they're maybe having a high score that file that they keep track of, or if you have some kind of game with a map, you actually create a map within your text file and then read it to show instead of hard coding it. So and those could be done by simple text files right here. So that's very straightforward. Now jumping into exception handling. So we'll actually analyze some of the code that we're seeing here. The first thing is, anytime you want to do something, we use the keyword try. So this is, we're telling Java to actually try something that could happen, or rather try to do something. And what we wanted to try to do is actually execute a line of code, or rather all the lines of code that are within this, this pair of curly braces, starting right here and ending right here. So I can actually give myself an output message, as a log, opened input file. So if it can execute this line of code, then it'll move on to the second one. And then if it can execute this one, it'll skip the catch sequence, and then it'll go to the next part of the code. But let's say if it could not actually access this file. So one of the examples that we had was I had a typo here. So this particular file, input files folder, and then the actual file called input.txt, this does not exist because this folder does not exist. So when we try to run it, it tries to execute this line of code, but it can't because somewhere along here, because we're calling the constructor and the constructor here, it's not able to do something, which throws an exception, which then gets caught right here, and then it does whatever we want it to do, is essentially print the stack trace, meaning print all this stuff, and then exit the system. This is where the catch comes in. Now, we can be catching different kinds of exceptions. The very basic one is called just an exception, but we have more specific exceptions that can be caught. I think there is or what we have right here, down here, is the file not found exception. Okay, and then import properly. And then we say system.out.println file not found, and system.exit. Question is, can we do anything with the catch, like create a custom output message saying you have an error or something like that? Never mind, you just answered that. Yes. Great question. You know exactly where I'm going with this. When we have different types of exceptions, we can handle them in a different way. So for example, if a file was not found, maybe I can write some code to say, create this folder and create this file, just so that something is there for future. Otherwise, we can say, oh, we actually want to print an error message and then exit. And then based on which exception that we're catching, it would print out it would try to access the code appropriately. We have the most specific exception here. So this is where we have inheritance and polymorphism going on. We have the most specific, or the most child exception class here, the file not found exception, and then the parent class here. So it's very specific up here, and then when it keeps going down, it gets more and more generic. Eventually, one of these has to match. So when we actually run this, instead of actually going to this line and exiting, we actually go towards this line, and then we exit. This is catching multiple exceptions. And then once again, we want to have the generic, the most specific ones at the top, and then the more general ones at the bottom. And usually the least one is supposed to be the most generic exception, which is just called exception. And then the reason we have this statement like this, where we have scanner scan equals null, and then scan equals blah 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 in the try, we could have done this way, but this causes another issue, and that has to do with the scope of the code, or rather the scope of the variable. Now, anytime I know this is a bit off topic, but I've seen a lot of students get confused by this, so I just want to cover this right here. Anytime we declare a variable, we declare it within a pair of curly braces. So in this case, we are declaring it within this try block. That means that this variable is not available when these curly brace pair ends. So after this curly brace, the closed one, the scan variable is no longer available. So that's why, when we declare it up here, it's actually between this curly brace and the one down here. So the scan method is available throughout this whole method. If we were to create, let's say, an instance variable for scan, or rather, an instance variable for scan equals null. So since we are out of this particular curly brace, we cannot access this this variable. So that is the reason for us to declare the variable up here, and then we initialize it to null, and then actually set up the value within the try block. Then we do the same thing when we have our print writer. We create the variable here outside the try block, then we set the value here, and then we use it throughout the rest of the method. Now, exceptions aren't something that are only used by Java, or rather only used by the classes provided by Java library. We can actually throw exceptions ourselves. So I'm going to create another class, and I'm going to call this Sometimes I'm terrible at coming up with names on the spot. Example class. And now what this is going to do is going to have rather instead of saying example class, I'm going to rename this to a ratio. Or rather a fraction. I think that might have been a better name. Actually, a fraction would be a better name. Which means we have a numerator and a denominator. It's not demon, it's denom. Then this dot num equals num, and this dot denominator equals a denominator. Straightforward. And then public double calculate. This one does something fairly straightforward. And that is, it just divides the numerator by the denominator. Now hopefully you can see where I'm going with this. And that is, so I'm just going to put this whole code as I'm just going to comment it out. So it does not interfere with what we've already done, but at least we don't lose it. I'm going to create an instance of fraction equals new fraction. The numerator is going to be 1 and the denominator is going to be 0. F dot calculate. So now if what I think I've done is correct, I should get a division by 0 kind of an error. Let's see what's going on here. What did I miss? I'm going to print the values to see what they are. Try to run it again, and this is working properly. Okay. Now this, I think this might have been a happy little accident, to paraphrase someone else here. Normally we don't want it to happen that that we shouldn't be able to divide by 0. We want to prevent that from happening in this class. So we can actually throw our own exception. Throws. We use the keyword throws here, and I think there's something called division by 0 exception. And I think that's built in Java. Okay, so it's not built in. So I think we can, we can say this class throws an exception. And then what we want to do is check if the denominator is 0, hello, Sir Daislot. Welcome to the stream. So what we're doing here is checking for our error case. And the error case is, that we're trying to do division by 0. If that is the case, that the denominator is 0, then we actually throw an exception. Otherwise, we can just do the division properly and return the value properly. So now when we actually try to call this f.calculate method, you notice here, maybe a bit difficult to see, but there is some kind of error here. It's underlined red, and it's telling me that I either need to add a throw declaration or surrounded by try and catch. And the reason I need to, normally what I would do is surrounded by try and catch. And the reason I need to do this is because this particular method that I'm calling, the calculate method, has this statement right here in the signature saying that it throws an exception. This is why I need to actually have this f.calculate statement in a try and catch. So let's say if I have some value, or rather, I just want to make sure that I keep track of the fact that I could actually make that calculation or not. So initially, I would say can calculate is a Boolean variable, which is initialized to false. But if it can reach this part of the code, then it is set to true. And in this case, with the exception, we don't want to do anything. Rather, when we catch the exception, and then at the end, we say, can calculate is essentially we just print out whatever the value for can calculate is. So if we run this here, we say that can calculate is false, meaning this particular line of code was never reached. And once again, this is because when we try to call this method f.calculate, it comes down here. It sees that the denominator is set to 0, so it throws the exception, which in turn stops this try block right here, and it jumps to the catch block. In this particular case, the catch block is empty, so it jumps down here, which in turn prints out this statement, can calculate false. So now if we were to do something else, 1 divided by 5, and run it, we see that can calculate is set to true, meaning we were able to call this exception properly, or rather we were able to call this method properly, which allowed us to get to this line of code. And then when the try block was completed, it jumped down here and printed this statement. And then I think just for earlier, we can do print the stack trace. Let's go back to the previous version. So you can see when I say print the stack trace, it shows that the exception type, it's java.lang.exception. It shows us the error message that we specified. So when you said throw new exception, and then within parentheses, we give in the string can't divide by 0, we see that being printed down here. And then this particular stack trace actually shows you what lines of code are being called. So it says that the code got down to this main method in our driver class until line 55, which in turn called this other method in our fraction class, the method being called calculate, down on line 14. It was able to get all the way down here, which in turn threw the exception. Okay. Does that clarify throwing exceptions and catching exceptions? Do we have any questions? I know this was a fairly a brief overview of exception handling, but I think it gets the point across, and at least the things that we need to do for this project, or for our projects, and hopefully the assignments and coding challenges in the future. see if there's anything else about exceptions that I'm missing. The one thing is, this is less about actual syntax and components. This is more about just thinking about coding and creating projects. Is that in some cases, when you catch an exception, you want to exit the system, meaning you want to stop the application because you can't go any further. So in our example here, when we are trying to read from an input file, and in case that input file doesn't exist, then we just stop the program because we can't do anything else. So this is why we have the system.exit statement here. Because if this fails, meaning if we can't read from the particular file, then we just stop the whole application. We can't go any further. But in this particular case, the one down here, even if we can't do this calculation properly, the program can still go on. We can do other things. And then that's what we do down here. So this is why we don't have a system.exit in this case. The point being is that you don't always need to exit your application as soon as you find an exception. There are ways to handle it. Things that we could have done up here is, if that input file didn't exist, we could have created an input file. Or we could have just said, input file not found, something like this, and then not do this thing, the rest of the code. Or actually, why don't we even do that? I'm going to get rid of these comments. So once again, what I want to happen is, if we can read the file, or rather if we can open the file, then we want to read and print everything from the file. So I'm going to move all of this within the try block, because this makes it all related to one another. First, it tries to do this line. If it can, it goes on to the next one, and then if it can do the second one, it continues on with the rest. This way, if we, and then we want to get rid of the system.exit. So if we run this, so we can see that, this one, there we go. This particular try block right here, it tried to create the scanner with this particular file. It said file not found. That's where this line is coming from. So it didn't even enter the line of this while loop, and it didn't even enter this log open input file, because that line is not there at all. So it moved on to the next part for our print writer. So if we open this file, it says it's been uploaded, and boom, we have another version of this right here. So we have more lines appended to it. Then once it's done the print writing, it goes towards our fraction example, and then it says the exception can divide by 0, and then can calculate is right here. Can calculate false. And then this here is the printing of the exception, the stack trace. Okay, so anyone have any other questions before we call it an evening? Okay, if not, bit of notices for the conclusion. So I will be posting this video onto my YouTube channel later tonight. Once again, if you're in CPSC 233, the link will be on the D2L page. If you're in 219, I think the link to my previous videos is already on the D2L for from the previous sessions, so it's the same YouTube channel, and then that's where the video would be posted as well. I know I hopped in late, but what you said made a lot of sense. Thank you. That's essentially the purpose of these sessions, is to make sense and then help you actually understand some of the concepts. That was a lot of info. Go study. You're welcome, and then thank you for coming. So yes, so yeah, the video will be posted onto my YouTube channel. I I will be taking a break next week, and that's because I actually get to give 2 guest lectures at a graduate level course, so that's really fun. Thank you, Storm, for the YouTube link right there in the chat. That's where you can find the same channel is where you can find the other videos. We will return in April. Keep an eye out on this channel and the D2L, at least for CPS 233, for when the next session is going to be. If you would like me to cover other topics, please fill out the survey right here. The link is in the description as well. Fill out the survey. One of the questions actually asks is what kind of topics that you would like to see covered. If you fill out the survey, even if you filled it out before, the questions that you answer could be related to today's session as compared to the previous session. So that if we have more topics to cover, we will cover more topics. Otherwise, we might just do one more session where we cover recursion. Okay. Thank you all for coming in tonight. Hope you enjoyed it as much as I did. Hope you learned something. And then if you have any questions, let me know. You can reach me either here, at my UCalgary address. I have my CT hours on Thursdays afternoons from 1 to 3 p.m. I'm also available on D2L and at least for 233 students. All right. Well, once again, thank you all for coming, and have yourselves a good night.